Hi there everyone. So I'm just going to do a quick example of a past exam question from the Yachtmaster Coastal Skipper exam of the secondary port calculation question that comes up. So it's just an example that changes on every exam. And so here we have it. It's generally always the last question. And so, for example, this one is at 1340 SPDST on Sunday the 30th of June. A vessel is anchored in the vicinity of Port Slade in a depth of water of 7 metres. What is the height of tide at 1340 SPDST? So that's part one. Part two, how far will the tide fall between 1340 and the next low water? Okay, and if the vessel's draft is 1.7, what will the clearance below the keel be at the next low water? So that's all fairly logical and nothing too much there. So I'm just going to start off by taking down the key points. So I will just start off with, so we're at 1340 SPDST. That's question 6. Okay, in the vicinity of Port Slade. Depth is, so the depth at 1340 is 7 metres. So what will the height of tide be at 1340? Okay, so this is going to be working towards part A. So first of all, I'm just going to find Port Slade. So I know Port Slade is conveniently the only port on the Neptune Islands, so that's going to be right at the back. And on page 96, we have Port Slade. So although Port Slade's in a different kind of region, it's still, the standard port is Colville, so I'm going to turn to the left to get there. Okay, and I can be pretty damn sure it's going to be an SPDST as well, because I'm in June. Okay, so just having a look at the differences, there's nothing too... Okay, well, we can see that the high water has quite a large difference there. Okay, so it could be 1.8 metres higher, or it could be 0.6 metres higher, so a total of 1.2 between these two. Bit of a difference there, but the times aren't too bad. So, anyway, let's go to Colville. One key point I forgot to put down is the 30th of June. Okay, so on the 30th of June, just so you can see, June, down here, 30th, last day in June, I'm going to plot a quick old, make sure I don't read the wrong one. So 1340. SPDST is going to fall somewhere in between the middle two tides. So I've got my... So let's just go Colville's green, why not go for... So Colville is... First it's going to be low water at 0918 at 1.2 metres. And high water is 1530 at 4.3 metres. Always worth checking what time zone is this in. This is in time zone TZ -1. Okay, so these times are TZ -1 or UT +1. So that's cool. So we'll come back to that, and we're going to work in whatever time zone the standard port information is in. That's what we're going to work in at this stage. And we're not going to convert it, if necessary, until the end. Okay, whilst I'm also flicking through, Colville is a high water curve, because high water is at the centre, so then I know, great, it's the high water time that I'm interested in, not the low water time. And what I'm just going to do is put a line through that one, just to make sure I don't accidentally read off my low water time. Okay, then I'm back to Port Slade. So the first thing I need to do, I'm going to be converting all three of these into the Port Slade equivalent, and then I'm going to be going to the Colville curve and inputting my adapted times and heights into that curve. So I need all three bits of information to plot a curve, and then I'm going to use that information from the curve to find out what was the height of tide at 1340. Okay, so starting off with the differences. So I'm going to start with high water. Okay, so high water. High water is 1540 and 1530, sorry, and 1530 falls in between 1300 and 1900. Yeah, so I'm going to be firstly plotting myself a little line just for the 6 hours there. So I'm just going to go, so I've got 1300, 14, 15, 16, 17, 18, 19. Happy days. Okay, and 1330, 1530, oh sorry, I'm getting the wrong name, is going to be there. So that's the time that I'm going to be interested in. So now I'm going to plot my differences. And so I always do my differences on the top part, the sort of angled part. There's nothing wrong with doing two lines parallel to each other. The problem is that what happens is you can't get the scales to match up because you need to start and finish at the same time. So I find it easier just to do a angled crocodile teeth style line, and therefore it doesn't really matter what scale, etc. you use. So at 1300 I have minus 45, and then at 1900 I have minus 35. So I've got 10 minutes. So I could just break that up into 5 divisions of 2 minutes. So starting off with minus 45, 43, 41, 39, 37, 35. Okay. Yeah, and so the key thing to note here is that the 1300 and minus 45 must be at the same end, and the minus 35 and 1900 must be at the other same end. And so just to plot these two together, I've got just going to stick this line on here, and I just need to connect these two with a line, and then what I'm going to do is just parallel slide that down here until I get to my 1530 mark, and that's going to take me straight to the minus 41 minutes, bang on there, so that's nice. So I know that my difference in my difference in high water time is 41 minutes earlier. So minus 41 minutes. Okay, so we'll add these all up at the end, but we could just do it now. So that's going to give me, 1530 minus 41 minutes is going to take us to 1449. So Port Slade, high water is 1530 minus 41 equals 1449, and that is TZ minus 1 or UT plus 1, they're the same thing. Okay, so that's my first conversion done. Now I'm going to look at my heights. So high water is 4.3 meters, and 4.3 is kind of in the middle of these two. So I'm going to guess it's going to be around 1.1 meter plus, but I'm just going to go and draw crocodile teeth just to work it out accurately. So at my end of the scale I've got 4.8, so I'm going to start off with 4.8, and I'm going to 3.9. So I've got 0.9 here, so I'll go 4. I might as well just do 4.8, 7, 6, 5, 4, 3, 2, 1, 0, and then mark those off. I just need to add one more on the end. So on my bottom scale here, I could have simplified this, but I've just done quite a long one. So I've got 4.8 down here, and then just dropping by 0.1. So I'll just do 4.6, 4.4, 4.2, 4.0, and 3.9. So I've just missed out half of them there, just to speed things up a bit. Sorry, you realise you can't see that. So there we go. I've got my bottom scale to match this information here. So now I need to put my differences on. So at the 4.8 end of the scale, I've got plus 1.8, and at the other end I'm going to have plus 0.6. So total difference of 1.2. So if I go up in, I can go up in 2s, I can go up in 3s, or I can go up in 4s. It doesn't really matter here, so that's quite a nice one to have. So let's have, I'll just go up in 0.2s. So 1.8, 1.6, 5, sorry, 1.8, 6, 4, 1.2, 1.0, 0.8, and 0.6. So plus 1.8, 1.6, 1.4. Okay, so now I've got my differences scale there, so now I need to make sure I join my lines. Green last time. So I've got my green on there, and then I'm just going to slide that down, and my height of high water is 4.3, so I'm just going to come down to, firstly let's work out where 4.3 is. That's 4.4, this is 4.3 here. So there we go. So that gives me a difference of, well, somewhere between 1.1 and 1.2. So that's about what we calculated. So I'm going to add the lesser figure. Plus 1.1. There we are. I'm just assuming I'm going to have 10 centimetres less tide rather than at high water, which is just going to give me a better safety margin. Okay, so we can then work out, so port Slade, high water equals 4.3 metres plus 1.1 equals 5.4 metres. Okay. So I'm just going to put a general box around my answers so far. So I've got that, and now I'm going to nip on to the last one, which is the time of low water. So, the height of low water. Low water was 1.2 metres at Colville. Okay, so transfer that over here. 1.2. So here I can see, right, the scale is from minus 0.3 to plus 0.1. So a total difference of 0.4 there. And I've got 1.2, so I'm very much closer to the neap end of the scale. Okay, so let's just go for 1.4 to 0.5, another difference of 3. So I'll just call, so I just do 3, so I'll go 1.4, 1.1, 0.8, and 0.5. And I can work out pretty accurately. So 1.2 is going to be 1/3 of the way down there. That's the one I'm looking for because it's, yeah. Okay, and then my differences are going to be at this end of the scale minus 0.3, and I'm just going to do, let's give it inches this time, shall we? Make it a bit more accurate. Minus 0.3, 0.2, 0.1. Not going to work in inches, not long enough. Back to centimetres. 0.3, 0.2, 0.1, 0, plus 0.1. So plus 0.1, no difference. Okay, so there's my differences for this one. Parallel my line. And just going to slide that down. Minus 0.2. Simple. Okay, so minus 0.2. So the answer, say Portslade, low water Portslade equals 1.2 minus 0.2 equals 1.0 metres. Okay, so that's all my complicated secondary port stuff done now. Now I need to return to the almanac, find Colville, get my curve. This is where it's always useful if you rub everything out as you go, because I've got past example worked in here, so I'm just going to get rid of that. Okay, so first of all, high water. So high water Portslade was 1449 TZ minus 1. The question is asking us where 1340 SPDST. So these two are not in the same time zone yet. So what I'm going to do is I'm going to plus 1 hour. And that's going to give me 1549 SPDST. Okay, so that is now my new converted high water. So 1549 SPDST. Okay, and I need to go backwards in time because 1340 is before that. So 1540, 1449, 1349. Okay. So that's me sorted there. And then I've got my height, so I need to plot. So high water was 5.4 metres. 5.4 is there. Just check the scale. Yep, cool. And low water was 1 metre. Yes, 1 metre. Okay, so what is the height of tide at 1340? Well, that's basically 1350. So if we go back 10 minutes, that takes us to 1 notch to the left, a bit further back in time. And so I'll follow this up with my rapidly blunting pencil. Okay, that's slightly to the left, so I might go from the upper end of that line. And that is going to give me height of tide of somewhere in the 4 to 4.1 region. So, height of tide, 4.1 metres, so. .1 metres. So that gives us, coming back to the question. Question A, what is the height of tide at 1340 SPDST? Great, got that one. Tick. A. B. How far will the tide fall between 1340 and the next low water. Okay, so we had a look at the next low water, I believe. So the next low water is going to be 1 meter. Now, there's a slight complication in this question in the fact that we've calculated our low water was actually the 09, the morning low water. So the next low water is actually beyond high water and is going to be this low water here. Our low water, 1.2 metres, which we've converted at Port Slade to 1 metre, is this low water. So there may be a difference between these two. So I'm just going to take a quick look back at June and just see, because this is where these questions like to throw a spanner in the works. So June 30th, so low water was 1.2, the next low water is 0.9. So my next low water is quite possibly going to be a bit lower. So I'm just going to have a quick conversion of my... Okay, so next low water Colville equals 0.9. So what is 0.9 going to be converted to? Well, let's have a look. I've already got my scale here. Okay, so I've already drawn this. So I just need to slide this along. So where is 0.9 on this scale? 0.9 is going to fall 1.1, 1.0, 0.9, 0.8. So there's my... So that's going to be only subtracting 0.1 from it. So Colville equals 0.9. Port Slade equals 0.9 minus 0.1 equals 0.8. Okay, so there's my next low water. So if my height of tide is 4.1 metres, the fall of tide, so the fall of tide being on the curve, currently we are here, the tide is going to be rising for a few hours and then it's going to be dropping to low water. So the fall of tide is what is the height of tide now versus what is the height of tide at low water. And that is a simple subtraction. So we have 4.1 metres right now minus the 0.8 at low water is going to give us 3.3 fall of tide. Okay, so that is my answer for B. Oops, 3.3 metres. Okay, so just a little bit outside the box required there because it was asking us, you know, it'd be very easy to say, oh, well, low water was 1 metre. So it would give you a different answer of 0.2 of a metre, which at the end of the day isn't enormous, but in terms of being accurate, it's not quite, you know, what the question is looking for, so you may lose a mark there. Okay, and then we're going to go, final one is part C. The vessel is a draft, the vessel's draft is 1.7 metres. What will the clearance below the keel at the next low water? What will be the clearance below the keel at the next low water? So part C. So this is going back to the original information we were given. So at 1340, SPDST, the depth of water was 7 metres. So where our boat is right now, it's 7 metres deep. Okay, and so we know that at 1340, the tide was 4.1 metres. Okay, so if we know that, then again, we can work out our depth was 7, but the 4.1 metres of that was tide. So that is going to give us a depth below chart datum. is just going to be 7 minus 4.1 is going to equal 3 point, no, 2.9. Let me double check that. 7 minus 4 equals 3. Yeah, cool. 2.9 meters chart datum. So that's not the answer. So we just know that, right, that's how much depth we have at chart datum. So in that case, low water, the next low water was 0.8. So we're going to be depth at low water equals 0.8 plus the 2.9. Okay, so that's going to give us equals to 3.7 as our total depth. And then we've got a keel of 1.7. Keel equals 1.7. So in that case, 3.7 minus the 1.7 of our keel equals our lovely 2 meters clearance. So quite a few different parts going on there. It's relatively logical, but it can be a little bit hard to work out, oh my god, what do I need to do? So we know what our depth of water was at 1340. We know what the height of tide is at 1340. So from that we can work out what is the charted depth. The charted depth equals 2.9 meters. Okay, great. If we know the chart datum depth is 2.9 meters, and the next low water was going to be 0.8. We add them together, that gives us 3.7, and then that's the total depth of water. And then our keel was 1.7, so 3.7 minus the 1.7 equals the leftovers clearance, which is 2 meters. I hope that's relatively straightforward to follow. I can do more examples if you want. Please stick any questions in the comments. Thanks very much. Cheers. Enjoy your bank holiday.